the outcome of the trust bootstrapping process. From a subject perspective, it is a credential. And it is a credential that is used to authenticate the subject because in future interactions, we want exactly that to have guarantees about the subject that the other one is interacting with. And this is associated to the identity that was verified in the previous step. The credential could be in the manner of a cryptographic key, or it could be something more traditional like a password knowledge base or TOTP or FIDO. Any credential that later an authentication can be associated to the identity that was just verified. And in general, in addition to the credential, any cryptographic material could be added to this output for any needs that might be required for the use case. The credential, typically in the majority of scenarios, is centralized. So one goes to a particular um, service provider where you create an account, and as part of that process, the identity is verified, and that information is remains in just that service provider, and which is the reason for the centralized name. And in some instances, that service provider might federate the use of these credentials and this identity to allow to go to some other places and perform some other operations. The other way in which the credential can be managed is when the holder actually, or the subject is who actually keeps and manages this credential. In that way, it becomes truly decentralized. So whenever the subject requires to use them, it just presents the credential to the service provider that is offering a service to them. Examples of this is the centralized identifier specification and the verifiable credentials. So those are examples of credentials that can be presented directly by the holder of that credential. The credential and the cryptographic material that might be the result of the bootstrapping could be used for different purposes. The obvious one is the authentication, I already mentioned before, but there might be needs for encryption or signatures or key derivation that can also be addressed as part of the bootstrapping. Now, the credentials so far, we've mentioned the public aspect of the credential, but in order to be able to authenticate, so there is the private aspect associated to the credential. And a very important topic in that is how do you keep that private credential from being accessible to anyone other than the real subject. The best way is to use a cryptographic module like an HSM or a TPM or a secure enclave where that hardware keeps the private material within the limits of that hardware and it never leaves it. And then the model offers cryptographic operations that are performed locally, and then only the output of those primitives is what comes out of that hardware. And then in reality, in many instances, the way that it's done is the private material is in a data repository, maybe encrypted, but it is in a data repository that then an application loads from that repo, loads the private material, which in some way it's decrypted, and that private material is kept in memory, and that's where the crypto primitive is applied.